Hi guys, this is Mrs. Gassler, and in this video we're going to talk about solutions, the basics of solutions, so some definitions about solutions and how they're formed, and the parts of solutions. Should be a pretty short video. So we're going to follow through here and fill some stuff out as we go. And the first definition that we're going to start with is a solution. A solution is a homogeneous mixture. You might remember homogeneous mixture from last semester. In a homogeneous mixture, you can't see the parts. All these samples are uniform. It's uniform throughout, so it's a homogeneous mixture. And in a solution, that is the case. The opposite of a homogeneous mixture is a heterogeneous mixture, and in that one you can see the pieces. Think about a chocolate chip cookie. You can see the chocolate chips. There's definitely different parts. In a solution, that's not the case. You can't see the pieces. So it's a solution. It's a homogeneous mixture in which a solute is dissolved by a solvent. Okay. In a later episode, we'll understand how that dissolving process works. But that's the basic definition of a solution there. Remember, it's a homogeneous mixture. Our next definition, in order to understand this first one, is what's a solute? Well, a solute is, there's two ways to think about it. The first way that you can think about it is that it is what's being dissolved. If you put some salt in some water, the solute is the salt. The salt is being dissolved in the water. But sometimes you can make a solution out of out of gases or liquids. And so it's harder to think about that as far as what's being dissolved. So another way that we think about the solute is it is what there is less of, which is true even when we're talking about what's being dissolved, but the smaller amount is going to be your solute, okay? If you can't tell whether it was the solid being dissolved or not. Now the solvent, again, here we'll do this, there's the 2 stars. If the solute is what's being dissolved, the solvent is what does the dissolving. What does the dissolving? So when you put salt in water, it is dissolved by water. So water is the solvent. Okay. Now sometimes, again, if you can't tell what was dissolved and what was doing the dissolving, then the other way to think about it is it's what there is more of. Okay. What there is more of. And the universal solvent, just about everything dissolves in water. Not everything dissolves in water, but most things dissolve in water. So water is thought of as the universal solvent because you can dissolve ionic compounds and you can dissolve polar covalent compounds. And nonpolar compounds don't dissolve in water, but that's just a small portion of it. Okay, so the next thing we're going to talk about briefly is some common solutions that you might come across in regular everyday life. In fact, almost everything that you can think of is an everyday solution. This table is probably a solution. I can't see the parts, and I know it's got different pieces in it, so it's technically a solution. It's a solution of solids. Brass is a solution of solids too, but here's some that we'll discuss. Air is a solution. You can't see the parts. There are some things dissolved in the air. If you think about it, so it's what, 71% nitrogen, maybe it's 70%, and then it's like 21% oxygen, and then, various small percents of other things. Like argon and carbon dioxide, those make up the other 2 big ones. Nitrogen, because there's the more of it, this is the solvent. Nitrogen is the solvent in our atmosphere, and then because there's less oxygen, that makes oxygen the solute. So if you want to think about it that way, oxygen is dissolved in our atmosphere. That's a common solution there. Tap water is a solution. It has pure water and minerals and other things, minerals and metals that are dissolved in the water, and those would be the solute because they are dissolved in the solvent that is water. Now pure water is not a mixture, it's not a solution, but if you get tap water, it most definitely has some things in it. which you knew from watching the video that then when they treat the water, they put things in it. Another one, and this one is my favorite, is soda. Soda is really interesting. So this is a gas, air is a gas mixture. Water is almost a solid liquid mixture because those solids are dissolved in the water. Soda is a liquid and gas mixture. Because the liquid, which is generally water and maybe some other flavorings, and the gas that's dissolved in it is carbon dioxide. Carbon dioxide, you don't think about it this way, but the water is the solvent, and the carbon dioxide is the solute. And when the water, what they do is they run carbon dioxide through, pressurized through the water, or in a variety of ways, and that dissolves the carbon dioxide in. When your soda goes flat, that means that all the carbon dioxide has left, and it changes the flavor of your soda. So the carbon dioxide tastes a little bit sour, a little tart maybe. When you drink the soda with the carbon dioxide dissolved in it, it tastes like yummy soda. And when you don't have the carbon dioxide anymore, it tastes terrible. And that's why. Now you understand why soda is yummy. All right, so that's it for this first objective here. The objective we talked about was to define a solution and distinguish between solute and solvent. Thanks for watching. Let your teacher know if you have any questions. Hi guys, this is Mrs. Gassler, and in this video we're going to talk about the concentration of a solution from a conceptual standpoint, not mathematical yet. We'll do the mathematical one later. All right, so to begin with, again, we're talking about concentration. When we talk about concentration, we're talking about how much solute is dissolved in the solvent. Okay, so remember the solute is what's being dissolved and the solvent dissolves it. And when we talk about concentration, we're referring to how much of each, what's the relative amount. Okay, so when we talk about we use the word dilute. Dilute means there's not much solute, okay? And in a concentrated solution, there is a lot of solute. Okay, now it depends on how concentrated it is, but we can compare two solutions. The one with less solute would be the dilute solution, so I'm going to write that here, less solute. And the one that is concentrated would have more solute, and I'm going to say per solvent here, because I'll show you in a minute that it kind of depends. Okay, so so let's take a look at some solutions here. I have here 4 little cups of water. They all have the same amount of water. So what we're going to do is we're going to start with a dilute solution here on the left, and I'm going to swirl it around. Okay. Actually, that looks pretty concentrated, but you'll see that as I add 2 drops to this one, I didn't bring anything to start with in here. It's darker, and if I add 3 drops, 1, 2, 3, and then 4 drops to this one, 1, 2, 3, 4. There we go. You can see that it gets darker. So this is my dilute solution here. It's a little bit more concentrated, and then it is the most concentrated over here, where I put 4 drops in that 10 milliliters. Now, likewise, here's my 10 milliliters with 2 drops, okay, 10 milliliters. Here's also 5 milliliters and 15 milliliters, and I think that one's to 20. Is that 20? Yeah. Okay, now if I add 2 drops to here, whoops, that was 3, and 2 drops here, and 2 drops here, you can see that when I have more solvent, that I have a less dilute solution. Although I should have used bigger amounts, I didn't realize my, there we go. Okay, so if I wanted to put these in order from the dilute to the concentrated, I would have to switch the order. You see I have more solvent over here and less solvent over here, and that makes my solution more concentrated. So then another way that we would write this down here is to have more solvent, and this one would have less solvent. So what would you do if you needed to change the concentration? Okay, well, if you wanted to make it more dilute, here we'll put dilute over here, and we'll put concentrated over here. If you wanted to go from dilute to concentrated, you could do one of two things. You could add solvent to make it, add solute. If you put more of the solute in there, then you'll be able to have a more concentrated solution. Or you would remove the solvent. Now sometimes you can do that and sometimes you can't. In our situation here, I could just heat this up and boil away some of the water. In fact, when you do some cooking and you reduce a mixture in a pot on the stove, that's what you're doing, is you're making it more concentrated. You do that a lot when you make soups and sauces and whatnot. If you wanted to go from concentrated to more dilute, that's when you would add solvent. Okay, you can't really remove the solute. In most situations it's so dissolved that you couldn't possibly do that, but that would be something that I suppose you could do if you could remove the sugar, or maybe add less sugar than you were going to in the first place if you didn't want it to be quite so concentrated. Okay, so there's a couple of different terms that we use when we talk about concentrated solutions, concentrated and dilution. An unsaturated solution is one in which you could still, I'm gonna go with layman's terms here, you could still add more solute, okay, and it would dissolve. Think about it this way: I could continue to add more drops of water to here, and that water, or drops of food coloring, and the food coloring would continue to dissolve in there. It's not a saturated solution yet. At some point in time, maybe not so with food coloring, but eventually I have added enough solute that I can't dissolve anymore, and we call that a saturated solution. The maximum amount of solute has been added. Has been added. Okay, this is more noticeable with when you're dissolving solids, like there's only so much salt you can dissolve in water, and there's only so much sugar you can dissolve in water. If you want to dissolve more of it in the water and make a super saturated solution, what you have to do is you have to change the water, generally by heating it up. If you heat the solvent, often it can hold more. Sometimes it's cooling the solvent, but if you heat the solvent, it can hold more solute. The way they make rock candy is they have a super saturated sugar solution that by heating the water and dissolving as much sugar as they can, and they put a little string in there, and then as it cools down, it can't hold all that sugar, and so the sugar crystallizes on your string. It's actually pretty cool. So that's a little bit about concentrated solutions. In another video, you'll learn how to calculate the concentration, which is a valuable skill. Thanks for watching. Ask your teacher if you have questions.